Okay, in this how-to, we are going to find the inverse of a function. I've got three different examples going progressively from easy to more difficult. And the first one is, let's find the inverse of f of x equals 7x squared minus 3. Now, I should state that I am not discussing whether the inverse or the function actually exists. That is a separate how-to. All I'm doing is going through the procedure, the method of finding the inverse, okay? So first step, we rewrite, change our f of x to y, and then swap our x's and y's. And you get a mark for doing that, in IB at least. Okay, your next step is then that you want to rearrange for y. Okay, so I'm just going to make a little note. Rearrange for y. Okay, so we can do this in a couple of steps. First step, I'm going to add 3 to both sides. So I get x plus 3 equals 7y squared. And then I'm going to divide both sides by 7. I'm just going to switch these around. And then to find y, in order to get rid of the squared, I take the square root of both sides. And again, I'm not saying whether this function actually exists. I'm just going through the procedure to find it. Okay, on your last step, to get your final mark, you change your y into the inverse, okay, function. And you are done. Okay, so that is example 1. Okay, so the second example, f of x equals 3x plus 1 over x minus 2. Okay, this is a common one. Same principle, you change your f of x to y equals. You swap your x's and y's. And now I need to rearrange this so it is y equals, okay? So first step, I'm going to multiply both sides by y minus 2. Okay, now you may say that this is not making it any easier. I'm trying to get this so it's y equals. My next step though is the only thing I can really do here is to expand this bracket. When I do that, I get xy minus 2x equals 3y plus 1. My next step is to get all my y's together, get all my x's together. So I'm going to subtract 3y from both sides. I'm going to get xy minus 3y. I've got minus 2x equals 1. Okay, I've subtracted 3y from both sides. And then I want to get this negative 2x. I'm going to get rid of it from both sides by adding 2x. So I get xy minus 3y is equal to 1 plus 2x. Okay, now. Okay, so I'm going to continue up here. Sorry, apologies, I don't like doing this. You keep working down the page. At this point, I need to find out what y is equal to. Remember, my whole point is I want to rearrange this so it is y equals. In order to isolate the y by itself, I need to factorize out y. If in doubt, factorize. So y times x is yx or xy. Y times 3 is 3y. And then at this point you can see, okay, to get the y by itself, I need to divide both sides by x minus 3. And that gives me y equals 1 plus 2x divided by x minus 3. And to finish it off, you write it as the inverse. Okay, so that's probably as difficult as it would get in standard level. You may see the next example. It's slightly trickier again, okay? But it's exactly the same process. Switch your x's and y's, rearrange for y. Okay, so our final example. F of x equals 2x squared plus 7x plus 3. Same thing, I'm going to let it equal, let my f of x equal y. And then I'm going to swap my x's and my y's. Okay, and I need to rearrange this so it is y equals. Now, it's not as obvious what I do here. If this was an equation and this was just a number, so for example, let's imagine that this is just a, no. Okay, so let's imagine this was just an equation which was equal to 4. How would you go about solving this for y? It's essentially what we're doing. Well, you would make it equal to 0, and you would either try and factorize or use the quadratic formula. Okay, so it doesn't matter that this happens to be an x. I'm going to do exactly the same process. Okay, so this is an x. I'm going to make it equal 0 by subtracting x from both sides. I'm going to treat this x as if it is a constant. And I'm now going to try and solve this using the quadratic formula. Okay, so here's our quadratic formula. Now I've written it like ay squared plus by squared plus c. And in this case, I'm solving for y. Okay, normally we would be doing it for x, but I'm just keeping it in the same vein as this one because we want to solve this for y. Okay, so negative b, so that's the number in front of, sorry, I've written that slightly wrong. Let me just fix it. Apologies. Okay, so b is the number in front of the y, so that is 7. So negative 7 plus or minus the square root of b squared, so that's 49, minus 4 times a, which is the number in front of y squared, times c, which is all of this. I'm treating this as if it is just, treating that x as if it's a constant. All over 2 times a is 2, 2 times 2, which is 4. So I've got negative 7 plus or minus the square root of, that's 49, minus 4 2s are 8, 3 8s are 24. 4 2s are 8, and it's negative times a negative, so it becomes plus 8x all over 4. And so when I tidy this up, I'm going to get negative 7 plus or minus square root of 49 take away 24 is 25, plus 8x over 4. And to finish it off, I'll just do up here, change your y to the inverse function. So yeah, granted it doesn't look particularly very nice, but I have done exactly the same thing as what I did for the others. I swapped my x's and y's and rearranged it so it was y equals. And I treated this x as if it is just a constant, treated it just as if it's a number, okay? That is the harder end of the scale. And remember, I'm not talking about whether this is actually a function and whether it exists or not. That is a separate how-to. All I'm talking about is the process that we go through, okay? Have a look at these again and make sure that you can do it.